Okay, so today we're going to be solving the remove element problem on LeetCode. In this problem, we're given an integer array nums and an integer val, and we need to remove all occurrences of val and nums in place. And finally, we need to return the number of elements in nums which is not equal to val. If we take a look at the example 1 here at the bottom, we have an array called nums which is equal to 3, 2, 2, 3, and we're given val equals to 3, so we need to remove all occurrences of 3 and return the number of elements which is not equal to 3. In this case we have 2 and 2, therefore we need to return 2. So the way we're going to solve this is by creating two pointers, I and n. I is a pointer that starts at the beginning of our array, and n is the pointer that starts at the end of our array. And every time I is not equal to val, then we're going to increment it and point to the next value. Otherwise, if the I pointer is pointing, for like in this example, at a value that is equal to val, what we're going to do is we're going to replace nums at I with nums at n, and then we're going to shrink our array size by doing n minus 1. So what I mean is that we're going to now be pointing at 2, and we're going to keep replacing nums at I with nums at n until nums at I no longer is equal to the value. And every time we do a replacement, we're going to decrement n. And then finally what we're going to return is n plus 1, because n essentially represents the last valid index in our array. And since our indexes in Java start at 0, we're going to return n plus 1. So let's begin coding this. Okay, so the way we're going to code this is by first creating that pointer at the end, int n, which is equal to nums dot length minus 1. Otherwise, if it was nums dot length, we'd be out of bounds within our array since indexes start at 0. Then we're going to iterate through our array. So for int I equal to 0. Okay, the condition is as long as I is less than or equal to n, and we're going to skip the part where we change I so we can keep looping through the list for now. Okay, so just to reiterate the example in order to really understand the condition I less than or equal to n, what we're doing is that when nums at I is equal to val, we're going to replace nums at I with nums at n, and then we're going to shrink n, decrement n, so n minus minus, in order to point here. And we're only going to increment I when nums at I is not equal to val. So going back to I less than or equal to n, like I said, what we'd usually do to loop through an array is we'd say I less than nums.length and then I plus plus. What we're doing here is we're saying I less than or equal to n because after we shrink the array, obviously n is not fixed, and what n represents is it basically keeps track of the last valid position. And once I passes n, we know that every element has been checked in our quote-unquote new array. And if we just did I less than nums.length, then we would keep going past the valid part of the array, and we'd check garbage values, which we don't want. And then finally for the I plus plus part, which we'd usually see in the for loop, the reason I didn't include it in the for loop, and I want to include it later in the code, is because I want to safely check that nums at I is not or it is equal to val. Because if for example here 3 nums at I is equal to val, so I'd say nums at I is equal to nums at n, but that's still 3. And if my increment was still in the for loop, although my nums at I is still equal to 3, I'd now be pointing at 2, which is incorrect. So instead, the only time I'm going to increment I is when nums at I is not equal to val. So let's go ahead and begin coding. Okay, so first we're going to check if nums at I is equal to val. And if it is, we're going to say nums at I is equal to nums at n. And then we're going to decrement n. Otherwise, if nums at I is not equal to nums at n, we're just going to increment I. And then finally, we need to, after this has been processed, we need to return n plus 1. So let's submit and see if it worked. So yeah, perfect. I hope you found that video helpful, and thanks for watching.